Hello guys, welcome to the FY22 SUSECON. In today's demo, I'm going to demonstrate the Harvester 1.0.2 release. So Harvester can be installed in two ways. The first one is you can download the ISO image and doing a step-by-step configuration. And the second one is you can do an IPXE installation, especially for a batch install. And those additional assets will be required for a batch installation. Normally, when you're downloading the ISO image, you can probably burn it into your USB driver and plug into your system to do the ISO installation. Or if you are using a home lab and you don't have independent bare metal machines, what you can do is you can create VMs that support nested virtualization and trying to install Harvester inside your VMs to just do an experimental explorer. So in this demo, I'm going to give some quick walkthrough about the installation mode with the ISO image. So firstly, you can either choose to create a new Harvester cluster or join an existing Harvester cluster as a compute node. So in my case, I'm going to create a new Harvester cluster. The second thing is you probably need to choose disks where you want to install the Harvester OS. So in here, I got two disks. So there are some minimal hardware requirements like 150 gigabytes for the load disk. So if you have additional disks, you can either create a RAID to providing additional data volume disks, or you can add each disk independently to the host after the installation. So here I'm going to choose the VDA as a default OS disk. If you have additional disks, you can separate your VM data disks into a new one. And this can only be performed during the installation. You can also configure your customized YARN config for IPXE install. And it is highly recommended to separate your data disks from the load disks. The reason being for that is because separate disk will providing a better I/O performance for your VM data as well as a better isolation. So here I'm going to choose additional disks and configure your whole host name as a Harvester demo and select your management NIC. So you can select multiple NICs if you have, and for Harvester, it will automatically create a bond for you. So you can get a failover mechanism if you want to build a HA solution for your management network. And configure the bond mode and IPv4 method to request the IP from your DHCP server or router. And then let's configure the DNS server 8.8.8.8. And the next one is you can request a VIP from your DHCP server, or you can configure a static one if needed. So following by configuring a cluster token, for example, like a demo, where you use this token to allow other nodes to join the cluster, and the password to access this node specifically. So let me configure the password. And the next one is you need to configure NTP server. So NTP server actually is really important for your time synchronizations, which is critical to Kubernetes because, as you know, Harvester is using a Kubernetes under the hood. So it is recommended to configure the NTP server to make sure all your nodes has synchronized time across your cluster. And if needed, you can configure a proxy server, which can allows your cluster to access outside web data. And also, if you need to import access keys rather than using a username or password, you can just configure over here. So last but not least, you can configure additional Harvester configs that has been supported by the Harvester settings. So if it's not needed, you can just skip it. If you have one, you can hosting your HTTP config through an Nginx server, for example, and just trying to type the UI address here. So for here, I'm going to skip it. And after you confirm all the installation options, you can just go and click yes to install your Harvester cluster. So normally this will take 10 to 15 minutes, depends on how fast your machine is. And once the Harvester cluster is installed, you should be able to see the IP address and also the related version and the status of your Harvester cluster. Then you can using the IP address to access your Harvester cluster. Okay, so once your cluster is up and running, you can just go to your browser and type in the UI address you grab from the console. So by default, when you log into your Harvester dashboard, you will go to the overview page, which gives you general information about your Harvester cluster. For example, including how many hosts, virtual machines, and other resources you have. And you will be able to see cluster capacity and some cluster and VM monitoring metrics. At the end of the dashboard page, you will be able to see some events that are categorized into different object. So like the other traditional VM platforms, you should be able to manage your hosts, virtual machines, and some volumes and images. So as a first step, what you should do is normally you should go and upload in your own image for creating a guest VM. So in Harvester, we do supporting 3 types of images, including QCOW2, raw image, and ISO image. Here, I have already uploaded a few of them. So let's go to the virtual machine page to create our customized VM. But before doing that, let me just briefly introduce a concept called a namespace. So namespace basically is a concept from Kubernetes, which allows you to put a variety of resources into a particular namespace to providing a certain level of isolation. So in here, I have created one called SUSECON 22, and now I can create a VM inside a relating space. So let's call as a demo open SUSE 1. And in here, we have provided some VM templates which can help you to quickly spin up your VMs. For example, there are ISO raw and Windows ISO image template. You can always create your customized one if needed. So let me just go ahead and create my own customization. So I can specify CPU memory, select my SH keys, and on the volumes tab, I can select image as a low disk image. Of course, you can always add additional volumes if needed. And on the network tab, you can select required network configurations. So management network is come as a default for the Harvester cluster, but it doesn't provide a persistent IP. So the IP address will get changed after VM reboot. If you need to use persistent IP, you need to configure your own VLAN network. So for example, in here, I have already created one. And node scheduling allows you to scheduling your VMs to a particular node or nodes depends on the affinity we have defined. Lastly, on the advanced tab, you can do some advanced configurations. For example, in 102, we have introduced a new field called the run strategy. So previously, we're just using a running field to describe whether a VM should be running or not. But in real life, this is not enough to describe all the scenarios. For example, when you have a VM that currently shut down inside the guest OS, but the harvester will actually automatically restart the VM because its field is set to running. So by using the new field run strategy, you can just define your VM's run rules according to different strategies. For example, with rerun or failure, it will only restart your VM when its status is on failure. So for the previous case, you will just go into expected status instead of restart the VM automatically. And in the cloud config section, you can just define your cloud init scripts. For example, you can inject your SH keys, you can inject your name, password, and even some advanced script for some Terraform batch creation. And on the network tab, you can define more network configurations. For example, you want to bring up the second NIC automatically, so you can just add your network data. And in order to reuse your cloud init configuration, you can just create a template for it. So let me just go ahead and create this VM. So normally it will take a couple of seconds to just starting the VM, and let's just click and view its general status. For example, it will provide some basic information, volume status. And the second notable change after 1.0 is that we have provided a tab called Access Credentials, where you can do it in a dynamic key injection after the VM is started. For example, this would be really useful if you forgot to set your SH keys. In order to take advantage of this feature, a Qmio guest agent is required to be installed for your VMs. So once a Qmio guest agent is installed, you can just click Edit Config and insert access credentials to add either basic auth or add SH keys. You need to specify the user for your VM. For example, if it's OpenSUSE, the user will be OpenSUSE. Or you can define a new user if needed. So after you specify the SH users and select associated keys, you will just need to restart your VM to make sure your configuration is taking effect. So once your VM is up and running, you should be able to access your VMs either using the serial console or web VNC inside the dashboard, or you can just using your own terminal to SH access to your VMs using the IP address. For example, in here, I can just bring up my terminal and doing SH OpenSUSE at IP address. Yeah, because I have already injected my SH keys, so I will be able to log in directly. And let me just check the IP address. And by default, the ETH0 will be up and request the IP address through the VLAN network. Yeah. Okay, the next thing I would like to demonstrate is about multi-cluster management. So you can easily manage virtual machines, volumes, and image through a single harvester cluster view easily. But what if you want to do a multi-cluster management? What if you want to do a multi-tenant management? What if you want to manage your VMs and containers side by side? If you have the above concerns, probably Rancher is the right answer for you. So with Rancher, now you can just simply importing the harvest cluster and managing with Rancher. So basically, you can deploy Ranchers to any public cloud, or you can just spin up a VMs and deploy your Rancher inside the harvest VM. So in here, I have already deployed my harvest Rancher dashboard somewhere. And now let's try to importing my harvest cluster. By clicking the virtualization management tab, we can start to importing my harvest demo cluster. So the importing is really simple. You just need to copy paste the registration URL to your harvest cluster settings. So let's go to the advanced settings. Click cluster registration URL and copy paste the URL address. Okay, let's come back to harvest cluster and waiting for the agent node to be connected and the API to be ready for serving. It will normally take a couple of seconds or minutes, depends on the network speed of downloading the images. So, okay, so mine is ready. And after clicking the harvest cluster, I should be able to view and manage my harvest demo cluster like what I can do with a single harvest view. So for example, I can go to the host, virtual machines, and volumes to manage all my existing VMs. So the next thing I would like to demonstrate is about the multi-tenancy management. So let me create a user called a harvest project owner and specify the password. So this user will be a standard user. And after creating the user, I can go to my harvest demo cluster. And let's go to the project and namespace tab. So a project is a special concept from Rancher, which helps you to group a list of namespace into a particular project. So you can doing a project-based management. So the next thing I would like to do is let's move the existing SUSECON namespace to a particular project, for example, like a default. And let me assign the user, which is a harvest project owner, as a project owner of the default project. So let's click Save. And now let's open a new tab, trying to log in with a new user. So this user should only have a permission to view a particular project resource. So it's harvest project owner with okay, so after login, what I would expect to see is a cluster called the harvest demo, and with only access to view a particular project resources. For example, yeah, as you can tell, I only got 2 virtual machines are running, which are created previously with the SUSECON 22 namespace. Yeah, and also so volumes and the images I have created for this particular namespace. You can adding more users and doing or creating a more project and a namespace for your multi-tenancy management. So the next one I would like to introduce for you is with Harvest, you can also try to spin up your own Kubernetes cluster within Harvest through our Harvest node driver. So with Harvest node driver, you can actually just simply come to the Rancher dashboard page, create a related credentials, for example, Harvest demo to access our imported Harvest cluster. And let's specify a cluster name. This is guest Kubernetes demo. So in here, you can just specify how many VMs you want to create. So for example, with 2 CPU, 4 gigabytes memory, and the disks, you can select a specific namespace, for example, default, and a specific cloud image, for example, with Ubuntu. And a VLAN network is required. So for example, your SH user should be the user for your, based on your OS images you have selected. And you can always configure more options like Kubernetes version cloud provider is another add-on feature provided by Harvester to providing internal load balance feature and a CSI driver features. So you can just increase the machine count to 2 to 3 nodes, or adding additional work nodes if it's needed. Okay, so let's just go ahead and create our guest Kubernetes cluster. So what you would expect to see is by going to the Harvester demo cluster, you should be able to see the new VMs has been created inside your Harvester cluster. And it will try to assign different roles to particular VM and form a guest Kubernetes cluster precisely. So this is all done using the Harvester node driver, and it doesn't require you to do any menu configurations. So let's just take a look. Okay. So VM is booting. So you can tell there are 4 machines, and each machine has its own defined rules. Cool. So after the cluster is up and running, you can just managing this cluster as a regular Kubernetes cluster, and those resources are defined as a VM inside the Harvester cluster. Yes. Okay. Okay, so the last but not least feature I would like to discuss in here is about the upgrade. So starting from Harvester 1.0, now you can upgrade your Harvester cluster by simply clicking the upgrade button from the Harvester dashboard page when there is a new version released. And for air-gap environment, you will need to apply the version manifest YAMLs manually to your cluster. And also you need to hosting the Harvester assets like the ISO image locally with the Nginx HTTP server so that it can be downloaded or pulled for each node. Let me give an example. So let's go to the Harvester doc and the upgrade page. In here, you should be able to see how the version YAML looks like. And there is a step-by-step guidance provided by our engineers. So I would recommend you to walk through the documentation, read some warnings, and prepare links or resource earlier before you're doing the upgrade. So once everything is checked, what you can do is you can just click the upgrade button and select the desired upgrade versions. So for Harvester, currently we're only supporting you to upgrade from a last version to the next version. For example, with 101, you can select to upgrade to 102. So by clicking upgrade, it will trigger the upgrade automatically. So the first thing what it does is trying to pull all the images from the remote server. And once that is complete, for each node, it will try to preloading those images accordingly. And then we will try to start to upgrade those Harvester system components or services. For example, like Harvester itself, and also the Longhorn, the Kubernetes, all those related subcomponents we have used for Harvester. So after the system upgrade is complete, it will start to upgrade the node one by one. So in the current stage, we do recommend you to shut down your VMs first, not only to save the upgrade time, but also you will try to reduce the possibility of hitting some known issues. And after the VMs are migrated, you will try to bump the underneath Kubernetes version. When everything is complete, it will start just to upgrade the OS image that is currently running as an immutable OS. When every steps are complete, the Harvester will automatically reboot a node to make sure the configuration will take effect. So normally that will take 10 to 20 minutes per node, depends on your network speed and the machine resources. So after that, you should be able to see your cluster is updated to the latest version. So that's all for today's demo. And in conclusion, Harvester is an open source project, and all of our users and feedbacks are the biggest treasure to us. So your user experience and ideas have inspired and helped us to develop a better open source product. So please enjoy harvestering and sharing your feedbacks or ideas on our GitHub repo and the user Slack channels. So lastly, please enjoy the SUSECON and thanks for your time for watching the demonstration. Thank you.